Hello everyone, my name is Jelani and welcome to my channel that is dedicated to helping you improve and succeed at CXC Math. So now that the January 2021 exam is over, we need to shift focus now to the May-June 2021 exam. And what I thought I'll do is I'll introduce a new series where I go through different topics in the math syllabus from start to finish so that you could move from being completely lost all the way up to being able to answer any past paper question on that topic. So if you think that would be a nice idea, you could go ahead and follow or subscribe depending on where you see in this video. So that way you could stay up to date on whenever I post a new video and you could watch it one time. Also to kind of help to support my pages, so that way both of us will all be winning. So let's get into the topic here. First one we're looking at is matrices. And what we want to do is we want to go through a nice cool introduction to matrices in this video. We want to talk about a definition, specific types of matrices, and then maybe if we have time we'll look at how we add and subtract matrices as well. So let's start with the definition. So if we want to define what a matrix is, a matrix is just an array of numbers with m rows and n columns. So this definition here, it looks very formal, right? And I don't want to say that we don't care about this definition, but what is most important is that we understand what a matrix looks like. That's the most important thing. So let's see an example of a matrix, right? Let's look at this matrix here. If I do 1, 2, 3, and 4, 5, 6. So the numbers, no significance in the numbers. It's just random numbers, right? So this here is our matrix. So they're telling us that the matrix is an array or just a layout of numbers with m rows and n columns. So we could see that happening here. I'll highlight it for you, right? So this matrix here, we see here's one row that I'm doing in red here, and here's a second row down below. Now here's one column in yellow, here's a second column here, and here's a third column here now. So we see this matrix here has 2 rows in red and 3 columns in yellow. So actually what we will call this matrix, a 2 by 3 matrix, meaning it has 2 rows and 3 columns, right? And this way of how we call matrices out like this, saying a 2 by 3 matrix, is actually very important, right? What we call this, right? We say that this here is the order of the matrix. So whenever you get a question, if you ever get a question asking you to state the order of a matrix, they're just asking you to write how many rows multiplied by how many columns, right? And also I just like to point out here, some people may be a bit confused, but we're not actually multiplying this, right? So we're not gonna say 6 here, we're just gonna leave it as 2 by 3 because we're saying 2 rows by 3 columns, right? So that's how we call or define matrices like this, right? In terms of how many rows multiplied by how many columns. So what I want to do now, I want to go on to a new page here, and I want us to go on to talk a little bit about the types of matrices, right? Some special types of matrices. And the first type that I want to talk about here is I want to talk about something called a square matrix. And to talk about it, I'm going to do an example, right? In fact, I'll do two examples. So the first example, I'll do something like this. 2, 4, 6, 8. And the second example, I'll do something like this. I'll say, let's do 3, 6, 9, 12, 15, 18, and 21, 24, and 27. So a square matrix, if we look at these two matrices here, we could actually create a square inside them. See that? Could create a square by just tracing the outer members of the matrix. And a square matrix is just one that has the same number of rows and the same number of columns. So if we look at that first matrix here, we have 2 rows. We have 2 rows and we have 2 columns. So let me highlight it here. We have 2 rows right? And we also have 2 columns. Now in the matrix on the other side, the bigger matrix, we could look at it also and we could see we have 3 rows. 1 row here, 2 rows here, 3 rows here. And we have 3 columns. So this here is a 3 by 3 matrix. So what we're seeing is that a square matrix has the same number of rows by the same number of columns. So if you had a 4 by 4, a 5 by 5, a 6 by 6 matrix, all those things will be square matrices. Now I just want to put a little asterisk down here because this 2 by 2 matrix is what we focus on a lot in this syllabus. We do a lot of questions on the 2 by 2 matrix. So let's look at another type of matrices. So let's open a new page here, and we're still looking at types of matrices. And the second type of matrices that I want to look at what we call a row matrix. And a row matrix is a fairly simple concept to understand. A row matrix, let's have 2 examples again. So this is the first example here. Let's do 1, 2, 3, 4. And let's do another one here. Let's put -1, -2, -3. Let's do something like this, right? Again, the actual numbers don't really matter. These are just numbers I'm making up as we go along. So this row matrix, how does this look? We see an example here, but let's analyze it a little bit. So what a row matrix is all about is just any matrix that only has 1 row in it. So if we look at this first one here, the 1, 2, 3, 4, if we look at it, it only has 1 row. It has more than 1 column though, because look here, these are the columns. 1 column here, 2 columns here, 3 columns, 4 columns. So it has 1 row but 4 columns. So we'll call this matrix here a 1 by 4 matrix. Now this matrix here is another similar thing. It only has 1 row. But this time, this one has 3 columns. So we say that this matrix here is a 1 by 3 matrix. So a row matrix only has 1 row in it. Doesn't matter how many columns, but it only has one row. Let's look at another type of matrices. So let's get a new page here. So we're still on types of matrices. We just have 2 more to do. So this third one here now, we're gonna call this one here a column matrix. And if you think about it, we just did a row matrix. A row matrix only had one row in it. So a column matrix now only gonna have one column in it. So let's draw out some examples and see, right? So here's the first example. Let's do some bigger numbers. Let's do like 100, 250, and 1000. There's some bigger numbers. And then let's do another one over here now. Let's do some decimals. 2.5, 6.7, negative 2.1, and negative 0.4. So here's our second matrix here. And like I said, a column matrix only has one column in it. And we see that happening here. There's only one column in both of these matrices. Now the rows could be different. So in this one here, the first one, we have 1 row, 2 rows, 3 rows. So we could say this is a 3 by 1 matrix. And in this second example here, we have 1 row, 2 rows, 3 rows, 4 rows. So we can say that this here is a 4 by 1 matrix. So remember, a column matrix only has one column. The number of rows could be different, but it only has one column. Now let's look at the last type of matrix. And this one is a very specific type of matrix, right? So types of matrices, last one here. This one is actually called the identity matrix. And it's extremely special. In fact, it's so special that it's given its own symbol. The symbol it has is a capital I. Right? And we're not going to talk too much about it in this video. We'll save the talk about it in a later video. But I just want to show you it so you can start seeing it from the very beginning. The identity matrix is this matrix right here. 1, 0, 0, 1. It's a 2 by 2 matrix, right? It's a 2 by 2 matrix. And this one here, the numbers matter. The numbers matter in this one. So let me put that in red. The numbers matter here. So it has to be 1, 0, 0, 1. Cannot be anything else. If it's anything else, it is not the identity matrix. It has to be 1, 0, 0, 1. I just thought I'll squeeze this in at the end of these types of matrices, so you could start seeing it from the very beginning, but we'll focus more on it later on in this series here. So we'll bring this episode to an end. At this point here, we did a lot of stuff in terms of introducing matrices, and I really hope that you're able to learn something from it and benefit from this video. Again, if you found it interesting, be sure to leave a like, and if you think that you'd want to see more stuff like this, you could follow or subscribe again down those links at the bottom there, and you could check out all those pages if you'd like to support me. So again, I really hope that you're able to learn something, and I'll see you in the next video. Bye.